All right, in these last two problems here, we're going to use U-substitution to solve problems that are quadratic in form. In the directions on your test, I believe it's actually going to say use U-substitution. On here, it did not state that, but these are both excellent U-substitution questions. Um, so these should turn into some very basic quadratics, okay, which will factor very nicely. So on here, because they're going to be basic quadratics, you're going to want them set equal to 0 first. So we're going to start here, setting this one equal to 0. We're going to bring this 6 over, so you get 7 x to the negative 2 plus 19 x to the negative 1. Bring the 6 over, you get a minus 6 equals 0. And then we'd really like these to be like a squared, then just a non-square linear term plus a constant, so that it factors quite nicely. So what you're looking for is one term that if you square one term, you get the other term. So if you look at the lowest power here, that usually will help you find your u. So in this case, if you squared x to the negative 1, you would actually get x to the negative 2. So what we're going to let u equal here is x to the negative 1. And then you'll notice that if you squared the u, and then you took this value and squared it, that would actually get you x to the negative 2. So here's your u and here's your u squared. Okay. So now what we're going to do is we're going to go ahead and do the substitution. So this is going to be instead of 7x to the negative 2, we know negative 2 is u squared, so this is 7u squared. Plus, now we're going to replace this term here, so this is going to be 19 instead of x to the negative 1, that's now a u, minus a 6 equals 0. Okay. Now we have ourselves a quadratic without the nasty exponent, negative exponents. So here we're go ahead and factor, so we need to the opposite of FOIL here. And obviously the first term in each here, it's going to need to be a 7u and a u. And now we got to play around with factors of 6, and we're trying to get a 19 here. So using 1 and 6, either the 7 is going to multiply by the 6 or the 1, neither of which can get you a 19 when you combine them together, because it's either going to be 42 and 1, or it's going to be 6 and 7, neither of which will get you a 19. So we're probably going to have to try the other factors of 6, which is 2 and 3. So if you multiply the 7 by the 2, you get 14, and a 3 won't get you a 19. However, if you multiply the 7 times the 3 and the 2 times the 1, this will get you 21 and 2, which can get you a 19 when you subtract. Since the last term is going to be negative here, we know the signs are going to be opposite, so the values will subtract. So it looks like we're going to need a positive 3, so we get a positive 21 and a negative 2. And those are combined together to get you a positive 19. So now that we've got it factored, we can set each of these equal to 0. So 7u minus 2 equals 0. So obviously in that case, well, let's just work it out. 7u equals 2. So u equals 2 sevenths. And then over here, u obviously equals negative 3. Okay. So these are your values of u, which are not your final answers on this question because we know u equals x to the negative 1. Okay? So if we take our first value here of 2 sevenths and let that equal x to the negative 1, we know to bring the power to the other side, we need to do basically the reciprocal power, but the reciprocal of negative 1 is still negative 1. So we say x equals 2 sevenths to the negative 1, and anything to the negative 1 is just going to flip that. So in this case, x equals 7 over 2. Okay? So there's your one value of x. And that should make doing the other value of x quite easy. If we have negative 3 equals x to the negative 1, that's going to flip that over. Remembering that this negative does not make anything negative, so this does not affect that sign. This is a negative 3, and it's going to stay negative. So this is going to turn into negative 1/3 for your value of x. Okay? So that's problem number 29. Okay? Moving on to number 30. This one's probably a little bit more obvious. Looks like we have a m minus 4 and an m minus 4. This one's squared. This is to the fourth. So looks like our u in this case is going to be m minus 4, which makes your u squared equal m minus 4 to the fourth. Oops, sorry, this is squared. So u is m minus 4 squared, which makes u squared m minus 4 to the fourth. So now we can replace these. So this comes out to 8. Now instead of m minus 4 to the fourth, that's going to be u squared minus 10 times u plus 3 equals 0. So again, when we have ourselves a quadratic, not the nicest quadratic. So let's come up with our factors here. Now, since this is an 8, looks like we have lots of factors for options of factors of 8. So I'm going to skip the whole number first. I'm just going to go to the u's first. We know each term has to have a u. We know the final term here is positive 3, and it has to combine together to get a negative. So the signs have to both be negative, and factors of 3 are limited, 1 and 3, and since these are the same, we can just go ahead and plug in the 1 and the 3. So now we can just look for factors of 8 that can get us a 10, where one of them gets multiplied by a 3. And as you work through those, you'll find that 2 and 4 are the ones that work. This is going to get you negative 6u. This gets you negative 4u, which gets you negative 10u. Okay? So then your values of u, you add 1, divide by 2, you get 1/2. And over here, you add 3, divide by 4, you get 3/4. Okay? So then, once you have that, those are your factors of u. Okay? But those are not your final solutions. Now what we have to do is set each of those equal to what u is. So 1/2 can equal m minus 4 squared. Okay. Now you need to get rid of the squared, so you're going to square both top and bottom. So 1/4 equals m minus 4. And, oh, I just really messed that up, didn't I? Let's go back. See, sometimes we even make mistakes. How do you get rid of a squared? You have to take the square root. So that's plus or minus the square root of 1/2 equals m minus 4. Sorry about that. And we know we can take the square root of top and bottom separately here. So that's plus or minus 1 over the square root of 2. And you can go ahead and bring over the 4. So that's plus 4 equals m. And then you shouldn't leave a square root in your final denominator. So we'll multiply top and bottom by square root of 2. So that gets you plus or minus square root of 2 over 2 plus 4 equals m. So that's your one set of values here. And then we have to do the same thing for the 3/4. Okay? So on the 3/4 here, we've got 3/4 equals m minus 4 squared. Get rid of the square by square rooting. This one's going to be a little friendlier here, because when we take the square root of this, you get the square root of 3 over the square root of 4, and the square root of 4 is 2. That works out a little nicer. That's equal to m minus 4. Bring the 4 over, and you get plus or minus square root of 3 over 2 plus 4 equals m. Okay? So there's your second set of values on that one. Okay. Best of luck on the test. I would recommend re-going through any of the problems that you had difficulties with. All right.